So there's the first page. Anybody got any questions? No? Excellent. So that was out of 9. So you give yourself a mark out of 9. Oh, I'm sorry, Haley. Which one?
Number 4. I think you converted it further.
You went further?
Yeah.
So you said it was 6.5 yards. So you said 6 yards, 1 foot, 6 inches. That's cool. I will never take away from you for doing more work. Everybody cool? All right. The right answers are highlighted. Oh, that didn't highlight at all. The right answers are highlighted in bleu in a second. That's the right answers. But I will accept anything in the green range due to bad photocopying. And they're worth 1 each as well. Actually, I make this real easy. I think I make this whole thing, every answer is worth 1 mark. Because it's all just filling in formulas. And finally, the painting question. 10.5 liters. But I would also accept it if you said you had to buy 11 liters. Even though I don't say anywhere that the paint is sold by the liter, I was willing to accept it. So that makes that whole first page out of 12. So give yourself a mark out of 12 if you're one of the persons that did the work. Any questions from the first page? Going once? Going twice? Third and final. All right. Moving on. Highlighted answers. 1 mark each. So that's out of 2. That's out of 2. I will go over any of them that need going over. Everybody okay?
Can you go over the 20?
Yes. Which one? Surface area or volume?
Surface area.
Surface area. All right.
Or no, sorry, volume.
Which is it?
Volume.
Volume. Okay. Is that a prism?
Yeah.
What is the volume of every single prism? Area of the base times the height, yes? The base is not the bottom. The base is the repeated shape, yes? So isn't that shape repeated for a height of 20?
Yeah.
So if you know that blue area, multiply by 20, you have the answer, yes?
Yeah.
How do I find that blue area? What shape is this part? It's a rectangle, so it's 8 by 4, yes?
Yeah.
What shape is this top part? Triangle, right? I told you there is 6 and there is 6, yes? And that's a 90 degree, right? So if I turn that triangle this way, oops, that's 6 and that's 6, isn't that the base and height? What's the area of a triangle? Base times height divided by 2. What's 6 times 6? Divided by 2? 18. Right, 18. So how big is this part? 18. What do you do with 18 and 32? Add them to get 50, yeah? What's the height? What's 50 times 20? 1,000. I know, because why? What was it that got you? Was it turning it sideways? I can't stress this enough. Base is not the bottom. I could go back in the videos and count how many times I've said base is not the bottom. Right? Stop thinking about the base as the bottom. Jordan.
Can you do 29 surface area?
29 surface area. Yes, I can. The way I would do this is I would consider it an entire rectangle, right? And then I would subtract this green part, because that's the only part that's lost, right? This is 2, and this is 9. So this green part is 18, agreed? And then I lose that green part again back here, right? Agreed? So if this thing was an entire rectangle, it would be 2 WLWH HL, right? Minus 36. Understand? So what I do here is I go 2 and I go all of it, remembering that's 4. So 4 and 18, that covers W, 2 of them, plus 8 and 18, plus 8 and 4, and then I minus out that 36, because that's what was lost. So 4 times 18 is 72, plus 8 times 18 is 144, plus 8 times 4 is 32. Then I add all that up, multiply it by 2, take away 36, which I can't do in my head very fast. But I'm willing to try if you want. 144, or that's 72, 6, 3, 236, and 32 is 268 times 2 is 520, 536 multiply. No, I did it wrong because I did it in my head. But anyway, that's what I do. Most of you guys probably did that area times 2, then that area times 2, and so on and so on and so on. Just added it up, which is perfectly okay. Did you have your hand up, Haley? Uh-huh. How many of those do I need? 2 times 2. How many of those do I need? 2 times 2. How many of those do I need? 2. Now I already know that's 50, right? So that's 100 100 covers the blue. And then that's 20 by 4, which is 80 times 2, so that's 160, covers the pink. And 6 by 20 is 120 times 2, so 240 covers the green. And then I got to remember the bottom. The bottom is 8 by 20, so that's 160. So then you add all that up. 320, 240, and 100. And you get 660. One mark down here because it's just filling in the formula. I will accept either answer, 628, whatever the decimals are, or 200 pi. For 1 mark there. And then the gummy bear question wasn't worth marks because it was worth gummy bears. So that page is out of 5. The gummy bear question is very, very, very difficult and wouldn't be on your test anyway. But it required a significant amount of math thinking to do. And everybody did essentially the same thing. There was a cylinder half full of water. Yes? So everybody did something with that cylinder. Jasreet found the whole cylinder and divided by 2. Rihanna did whole cylinder divided by 2. Taylin, you did the whole cylinder divided by 2? Yeah. I did just the volume of the water. So just this part. And then when you drop in the prism, When you drop the prism in, what's going to happen to that water? What?
Rise.
It's going to rise. So when you drop in the prism, the water rises to here. Then I found that volume. And then I subtracted to find the, because the water goes up to 26.79. Because the new water is still 64 pi, because that's 8 pi squared. Wake up. 64 pi h, right? That's the new water's volume. But that has to be the same as the old water's volume, which was 64 pi times 25 plus the 360 from this guy. So once you added that up, then you did algebra to find h. And you find that h was 26.79. The original height was 25, so it rose 1.79. That's how I did it. Back page. Only two. I accept 864 pi or 2714 for 1 mark. And I accepted, I just wrote the numbers there. I don't know why I didn't write the rest. But that's worth 2 marks, making that page out of 3. So it was out of 3, and 5 is 8, and 12 is 20. Give yourself a mark out of 20. Now listen to me, please. Tomorrow when I give you your test, on the top of your test, you're going to write your name and that score. Whatever you gave yourself out of 20. Remembering that I have a list of who did the work. So if you left 18 of those squares blank, you better not tell me you got better than 2 out of 20. Do you understand what I'm saying? Excellent. Any questions? Lexi.
I think I might need help counting because I know I didn't do all of it, but I'm counting twice.
Every answer you got right. Well, I might have counted wrong. Let's check. 9 on the first page, 10, 11, 12. Second page, 13, 14, 15, 16.
Oh, okay. So
Each
the
blank.
The first page is out of 12 as a whole.
Yes.
Okay, thank you.
Okay. Everybody good? We will do one of these with every unit. There will be a review assignment just like this. It will be handled exactly the same way. You'll get some time in class to work on it. The rest of it will be homework, completion, and the first thing the next morning, I'll be checking it over. Okay? There will be 8 of those assignments plus other assignments throughout the year. Those assignments make up 30% of your grade. You will not have to memorize any formulas because you will get your formula sheet on your test. Okay? Okay. Test will be tomorrow. It is not an 80-minute test. I give you 80 minutes to do it. Understand? If at the end of 80 minutes you have blanks, fortunately, I'm giving you the test on a Wednesday, so it bumps right into lunch. You can stay late. If you need to stay past lunch, then you don't know how to do the work. And you should get the grade that you get. Right? Doesn't matter how long you give me to explain string theory, I can't explain it because I don't understand it. Doesn't matter how much time I get. If you don't understand how to do these questions, doesn't matter how much time I give you, you don't understand it. Which means you haven't met the learning outcomes, which means you should get that grade. Got it? That being said, I give you 125 minutes to do a test that should take you 40. Okay? Yeah, all right. Any questions about surface area conversions? This is your last chance unless you come and see me at lunch or after school today. Sweet. Let us move on, cabbages, to everybody's favorite. Well, not everybody's favorite. My personal favorite unit in all of math, trigonometry. I no longer have page numbers on mine. Discussion here, of course, because you all, of course, know the Pythagorean theorem. I just like to tweak it a little bit. Because all of you know the Pythagorean theorem as a squared plus b squared equals c squared, yes? Everybody knows that. You also know that a right angle triangle is made up of an hypotenuse. Where is the hypotenuse?
Directly across from the right.
Thank you, Carlin. It's almost like you've been in my class before. Somebody usually says, it's the longest side. How do you know it's the longest side? You don't. So I like what Carlin said. The hypotenuse, which is the blue side, is always across from the right angle. And I make a big deal out of this because I get very tired of students not being able to do Pythagoras if the triangle is drawn this way. And don't laugh, I have many students that say they cannot do Pythagoras if the triangle is drawn in any way other than that. And that, of course, is what we like to call in the business horse pucky, right? Good. So, there's another thing I want to do. That word across. From here on, the word across is going to be replaced with a different word. That word is opposite. So somewhere on your page, if you cannot remember that, please write across means, I lie, don't write across, dummy head. Opposite. And I want you to highlight that, underline it, put a Mrs. Bad Crumble cloud around it, put stars by it, I don't care. Opposite means across the shape. Across. Okay? All right. Now, the legs, which I am highlighting in green. Somebody tell me something about those. What do we know about the legs of a triangle? Of a right angle triangle, I should say. Nobody knows anything about the legs of a right angle triangle. They're straight. Excellent. What else? They make a 90-degree angle. Lovely. What else? Okay. Well, we'll talk a little bit about them. One, they are the shorter sides. And they are interchangeable. One of them might be A, one of them might be B. In the next question, the other one might be A and the other one might be B. It doesn't matter. Okay? Now, the reason I am not keen on this is because if I change the letters, those same kids that can't do Pythagoras, if I turn the triangle, all of a sudden can no longer do Pythagoras. I'll give you an example. Oh, look, there's an example right here. What letter is that? No. What letter is that? X. There you go. It's not a trick question. But Daniel, I have students that say, Mr. Myers, I can't do that question. Why can't you do that question, kid? Because there's no A, B, and C on it. Does everyone see the problem? I know. Yes, I know. I know that's exactly what you meant. The problem with it, Daniel, and I'll show you in a second why that's a problem, okay? So, how would you solve this? You all, of course, being not the kids that can't do math when we use a different letter, will do exactly what Daniel did, right? You know that that x is the hypotenuse, and you know that the hypotenuse is c. So Daniel will say to himself, self, if that's c, then this must be b, and this must be a, right? So then Daniel will say to himself, self, I can do this. A squared plus b squared equals c squared. 8 squared plus 15 squared equals x squared. 8 squared is 64, plus 15 squared is 225 equals x squared. 289 equals x squared. And then Daniel will make the next right decision that a lot of my students don't make. What do they always forget to do? Square root at the end. Because they think that if, here I am, they think that if I walk 15 steps this way and 8 steps this way, that somehow I am 289 steps away from where I started. And they hand in the work. Of course, Daniel and all of you will remember that x has to equal 17 because you square rooted that. Right? Of course. Now, let's have a look at b. B is the next one that causes kids problems because all of you memorize a squared, b squared, c squared. And the first thing you do with b is you go a squared plus b squared equals c squared. And then you go 12 squared plus 8 squared equals c squared. And then you go 144 plus 64 equals c squared. And then you go 204 equals c squared. And then you say, Mr. Myers says I'm not going to square root, but I'm going to square root. And then you square root 204, and you get an answer of, anyone? Square root of 204? Anyone? Huh? 14.28. And then you say x is 14.28, Mr. Myers. And what do I do when you hand that in to me? I do this. That was not effective. That was better. And then I get out my big red pen and I put a giant X through it. And then I go home and I cry myself to sleep. Because, of course, that is totally, completely, and unutterably wrong, isn't it? Why? Because you had c squared. It was right there. But because you're so used to learning a squared, b squared, c squared, instead of learning math, you learn that formula, you screw this up. Of course, what would you need to do this one properly? Jordan? C squared minus b squared equals a squared. And then you would fill it in. 12 squared minus 8 squared equals a squared. 144 minus 64 equals a squared. And 144 minus 64 is 80 equals a squared. So this answer would be the square root of 80, which is going to be almost 9, right? Everybody cool? All of you know this to easy peasy, right? All right. Now, without writing anything down, please have a look at this. This is the problem with a squared, b squared, c squared. Solve it. No. That's a B. Solve it. because there's two things that are very weird about that triangle that mess kids up because they only know a squared, b squared, c squared. Jordan. 18.44. Is that a reasonable answer? What about his answer makes it reasonable? Jordan.
On the question, B is just labeled as B, but it actually is.
Yeah, this is really the hypotenuse, isn't it? When I change that letter, I always have students that do it wrong. They do all the work, and then they give me the wrong answer. Why is 18.44 reasonable? Well, since that is the hypotenuse, it must be the longest side, correct? So that's a reasonable answer. I'm not even going to check it, because I believe you. The other thing that's weird about that question is, what do you notice about the way I drew those two sides? 14 is definitely visibly smaller than 12, isn't it? Does that matter? No. Okay? It doesn't matter. You use the numbers on the sheet, not what they look like. What if I drew it this way? Could you still do Pythagoras there? Why? Because it's a right angle triangle. Why is it a right angle triangle? Pardon? Because I drew that, right? If that is not there, can I do Pythagoras? With the question written that way, can I do Pythagoras? No, because it's not a right angle triangle. But what if I gave you this? What if I told you this was 18.44? Can you then put that symbol in there? Yes or no? 50-50, guys. If I told you that this was 18.44 and that was 14 and that was 12, could I put that symbol there? Yes. Because that would prove that those two legs squared added up to that, which means that has to be 90 no matter what it looks like. Everybody good? Okay, now take what you know and tell me what x is. Go. If I put this here, is Jordan right? Yes or no? Absolutely. He does that math. He gets this side, right? Which is the square root of 35 squared minus 20 squared, right? And then he does Pythagoras on the blue triangle and he gets the right answer. And it is indeed 26.9. Absolutely correct, Jordan. Good math. But what was wrong with how he started? Was he allowed to do what he did? Anyone? Was he? No. Okay. So why did I write it that way? Because I wanted to catch people. Now, somebody who got a different number, what did you do? Because now you know this question can't be done, right? The way I've drawn it, you can't do it. So what did you do, Lexi? Uh-huh.
Like that.
Excellent.
And so half of 35 would be 17.5.
Okay. So then you use Pythagoras to find this side, I assume.
I did. And so since the bottom line would be the same as the top line,
Uh-huh. So you said this.
is 17.5.
So you said that was 17.5. And then she Pythagoras. Yeah, on that triangle. Is that okay? Is everyone happy with that? It looks good, doesn't it? Right? I love it. It's great thinking, but here's the problem. Is that bottom line cut in half? It's not, is it? So are you allowed to assume that that is cutting that directly in half? Because if that's slightly bigger than 90 degrees, you're not cutting in half, are you? But, again, did you apply math to the situation? Does that make me want to turn cartwheels? Yes, because we are at the beginning of the unit, right? All these answers make me very, very happy that people were even trying it. Because I did it on purpose. I gave you a question you couldn't do yet to see what you would do with it. And I love that everybody did something with it. Who had 24.9? Who was that? Jordan, what did you do?
I did the
Same thing as Lexi?
no. I just kind of assumed that it was a
Yeah.
I did c squared minus b squared.
Okay.
For the big triangle and got 26.83.
Mm-hmm.
And then I did c squared minus b squared
Yep.
for the small triangle.
Absolutely. Now, the question becomes, again, at the beginning of unit, is this when we should be making these mistakes? Yes. If I do that, how easy is it? So easy, right? Because if I do that, then Lexi's way works and Jordan's way works, even though they got different answers, right? Everybody cool? Eden, what'd you do? Something similar, I assume? Yeah. Okay. What does it boil down to? What did everybody make that they're not allowed to do? An assumption. Okay? Everybody cool? There used to be a unit in grade 9 that actually covered making assumptions about shapes. But of course they took it out. Even though it was a logic unit, it was totally useful. And everybody who teaches higher level math wishes it was still there, but it's not. So, everyone's cool? The point here is you can't assume. You gotta know. So this one made it difficult. Now there's a lot of things I could have done. I also could have done this. What if I'd done that? Then how you would know how long this was, right? How long would this be? 20, and I could have done Pythagoras there, yes? Okay. I also could have done, that's about all I could have done. Everybody cool? Okay, let's look at the next one. Can we do the next one? What would you do? There is something you can do for sure in B. I'm going to color 3 sides. Which of those 3 sides can I work with right now and that I'm allowed to work with? Green. So what would I do? The green side, is it an A, B, or a C? C. Excellent. So how do I do it? What's A? Are you sure? Is it 8? No, of course it doesn't matter. I'm messing with your heads. 10 squared plus 20 squared equals C squared, right? So that's 500 equals C squared. So what does C equal? The square root of 500, right? Which is 22 point blah. What is it? Give me one decimal. 22.3, right? Now, can I do anything more? Why not? I don't know that colored triangle is a right angle. Is everybody with me? Okay. If I put that there, can you do it? And then what would you do? You would do A squared plus B squared equals C squared again. A would be 25 plus B squared would be 22.3 equals C squared. And then you would square root 25 squared plus 22.3 squared to get C. Right? And C would be X. It'll appear in a second. Okay? The point I'm trying to make in this unit, before this year, most of your work with Pythagoras was on one triangle, yes? Now, please notice you are using information from one to solve a second one. And possibly a third and a fourth and a fifth. Does everybody understand? Is the math any different? No. We just are stretching it out further. Is everybody cool with Pythagoras? Yeah? All right. Your next page should be a bunch of gigantic triangles. Is it? It is? Okay. For some reason, mine's in my book turned sideways. So give me a moment while I get that sorted out. You guys, if you have a ruler, it would be very good right now. So if you have one, grab one out. Anything that measures. If you don't, it's no big deal. You guys have those triangles printed properly, yes? Okay. Just let me get mine printed properly. I'm very embarrassed by this. I feel, do you? You're the best. Don't let anybody tell you different, Daniel. Even though I just messed with your head, you still think that? Aww. You know, it's that kind of trust that makes this thing work. To quote that stupid sports quote, teamwork makes the dream work. You know what doesn't make the dream work? New computers that work like crap. That doesn't make the dream work. That just makes the teacher look like a tool. When I tell my friends that I have this set up, their teachers elsewhere, they're like, wow, that's awesome. I wish we had that set up. And I was like, yeah, it looks real good on paper. Dun, 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 dun. There we go. Found it. Soft erasers are key. All right, now we're in business. Okay, so that's your sheet, right? So now we got to do some stuff that some of you may or may not know. Okay? First thing, triangles are named by their vertices. Vertices is the plural of the word vertex. What is a vertex? Does anybody remember from the 9th grade? 8th grade? 7th grade? Okay. What is it, Lexi? That. It's that. The corners. The vertex is where an angle happens. This is a vertex. Okay? So this triangle is named by its corners. So what would be the most logical name we could give this little triangle? Dave? It's a triangle, and we name it by its corners. A, B, C. Everybody cool? All right. So now there's a couple of rules that we need to follow that are really important when we're doing trigonometry. The rules are these. Vertices are labeled with caps. So the corners all get caps. ABC. Everybody cool? I could also name this guy BAC. I could name this guy CBA. As long as I go around the corners in any order, I'm okay. Is everybody all right with that? Okay. Vertices are labeled with capitals. Done. ABC. So what then would be a good... Now, I'm tricking you here. What then is the name of this triangle down here? You have to name it the same way we named ABC. Pardon me, Lexi? FED. Why? Because we went A, B, C. So we have to follow the same order. Everybody with me? Yes, the federales are out to get us. Robert made that joke already?
No. Oh, it was real fun.
What? What just happened here?
So the feds are after me for the jump from
Well, that was not a nice thing to say at all.
Yeah, I know.
Hey, you know what happened in my house last night? We were watching The 100. Me, my son, and my daughter, and my wife, and our exchange student from Mexico. And there was a time when all the grounders had their knives out and all the sky people had their guns out. And they were all staring at each other. And my son says, "It's a Mexican standoff." And my exchange student was playing on his phone because he had already seen the episode. He didn't even notice. But my son goes, "Oh my God, I'm so sorry." And I was watching the show. I didn't even really realize what was happening. But we missed the chance to ask someone from Mexico what they call a Mexican standoff. Right? You guys are from Mexico. What do you call a Mexican standoff? A standoff. We're already Mexican. Right? Yeah. It's like people from Brazil. What do you call Brazil nuts? Nuts. What do you call English muffins when you're from London? Muffins. So my son was all worried about it, but I realized I made a mistake. I should have asked Juan what they call a Mexican standoff. But then when you think about it, why do we call it a Mexican standoff? It's just a standoff. It's two guys staring at each other and neither one's going to give up. Why does it have to be Mexican? How is it any different if it was two Azerbaijani guys? Azerbaijani guys. Would we call it an Azerbaijani standoff? Or can Azerbaijani guys have a Mexican standoff? And then what would happen if it was two Azerbaijani guys in Mexico? So they're Azerbaijani, but the standoff is occurring in Mexico, so it's technically an Azerbaijani-Mexican standoff.
Oh my goodness.
I know, it's crazy, hey? It's like the United Nations. What happens in the United Nations when people bump into each other in the hall and they do that thing where you both go the same way for like 10 tries? What is that? A United Nations standoff? That doesn't sound good. Anyway, sorry. Sorry about that, guys. It was just funny to me. Well, so what? That's funny. I take this on the road. All right, so first thing, vertices are labeled in caps. Now we got to do something tricky. Triangles are made up of 3 corners, right? What joins the corners? The sides, right? The legs. So that's where it gets a little tricky. Sides are labeled in lowercase. And here's where it gets tricky. Side names are from the opposite vertex. So remember, not vertex, vertex. So remember, what does opposite mean from now on? Across. So if this is capital A, what side is across from it? Right over here. And that guy's named little a. Back in the old days, you guys called that guy BC or CB, didn't you? We don't do that anymore. So what does that make this side? Lil B. What does that make this side? Lil C. What does that make this side? Little zebra? Lil E. What does that make this side? Lil F. What does that make this side? Lil D. Okay? Now, on your next page, you guys have a big chart that you would be filling out if you all had rulers. But I'm not going to make you do that. Because not everybody has a ruler. Who does have a ruler? Daniel, please tell me the length of side little a. Lexi, please tell me the length of side little c. Who else has a ruler? Alyssa, please tell me the length of side little b. In metric, please. In metric.
8.8 centimeters.
So little c is 8.8. Little c is 8.8. Little a? 7.6. And little b? 7.2. Excellent. Now, who else has a ruler? Jazreet, please tell me little d. Who else has a ruler? Sam, please tell me little e. 14 exactly. Thank you. Who else has a ruler?
Oh, I did it wrong. I'm sorry.
Okay, Daniel, how long's little a?
4.5.
4.5? Okay. How long's little e, Sam? 11.5. And somebody do F while I giggle. I don't care who. Anybody, just give me a number for F. Actually, don't. Don't give me a number for F. We're going to call that F. So everybody should have filled in those 6. Now, please notice, down at the bottom here, can I compare side B to side E? Yes. Side B is 7.2 compared to what side E? 11.5. What math is that? What math is that line? Division. So what would that answer be as a decimal? .63, right? 626? Okay. What would side C and D be? 8.8 divided by 14. What's that? .628. So it's 0.63, isn't it? Right? What do you notice? They're the same. So then, what's A and F? What's A? 4.5. What's F? We didn't do it. But what will that have to equal? 0.63. Could we use that knowledge to find the length of F? How? 4.5 over F must equal 0.63, yes? Solve it. What does F equal? Does that make sense? Is an F the longer one? How long is F? Doing algebra. Jordan. 7.14. So 7.1. How long is F when we measure it? Somebody with a ruler measure it now. 7.1. Oh, wow, look what we learned. What does that tell us? Did the size of the triangle change the decimal when we compared the two? No. Because all of the angles were equal. We didn't measure the angles because we were kind of running out of time. So what does that tell us? That tells us the following. Good, I'm still recording. If two triangles share the same angles, they are what we call similar. And when we know that they're similar, if we take, everybody draw two triangles and label them A, B, C, D, E, F, and then label the sides properly. What did we just prove if I am comparing the same side? So what side on this triangle matches up with B? Which triangle over here, which side over here matches up with B? E. What side over here matches up with C? F. And what side over here matches up with A? D. So what do we know about all of those comparisons? C divided by F, B divided by E, and A divided by D. What do we know about all those fractions? What did we just prove right here? That they're all the same. Everybody should remember that from the 9th. Actually, you might not. Alyssa, you would have done that in the 9th grade because they didn't change the curriculum yet. How many of you have seen that before? That you can compare stuff that way? That's actually really important. I'm sad that's gone from grade 9 because that's what makes trigonometry work. Does everybody understand that? So we only have 8 minutes left. Let's take a moment, and I want to make sure everybody actually gets that. So I'm going to draw this triangle. You don't need to write this down, just look at it. Can you tell me how long little f is? You don't have to write it down. We're just finishing the day with it. Can you tell me how long little f is, knowing what you know? All the fractions have to be the same, right? So, do you see a fraction that you can make? What can I compare? I need two numbers to make a fraction, right? One from each triangle, and they have to be the same side. So what am I allowed to use? 14 and 17.5. So if I compare 14 to 17.5, how am I going to use that to find f? That has to equal another fraction. If I put 14 in the numerator, what over here has to be in the numerator of my second fraction? Why is it 10, Carlin? Because it's between x and dot, so it's got to be the line between x and dot, right? So 10, okay. And what would go here? F. And then we would solve. How would we solve? Two ways. You could cross multiply, or you could find that decimal and then do algebra. Is everybody cool? I apologize, you guys. I thought that you all already knew this. I was not aware. Because last year I only taught Honors 9 and we did this. So if you were in regular 9, you may not have seen this. I apologize. So tomorrow, you're going to write a test, obviously. On Thursday when you come in, I'm going to do a few questions with this to make sure everybody's cool with it. Okay? That's on me, not on you guys. Sorry about that.